So this is about speed versus velocity, and CK12 kind of talks about it, but I want to make sure that it makes sense. I had to come up with a letter because they confuse things about what things are. So we're going to probably stay with the V, but I just want to make sure you guys understand what's going on with things. Okay, so speed. The big thing is that speed is total distance. So you've got to keep that in mind. It's total distance versus velocity, which is displacement. Now remember, we already talked about distance versus displacement in the last one. So if you don't remember that, go back and watch that video. But distance is how far I actually walked. It doesn't matter what direction. Direction doesn't matter. Whereas displacement, it's how far I actually am from where I started. In both cases, this is the same, right? The total time. So the total time doesn't change. So I decided I wanted to use different letters, and I've seen it in different books of how they do it. So I think S makes sense to you guys because it's speed, which is distance over time, which we'll use D. I saw in CK12 they're using D for delta X. As we go on in this, we might do the same thing, but I just want to make sure at this point in time you understand the difference. So this is distance. This is the difference in position, which is displacement, which is the true physics term for it. And then I use V for velocity. Technically, this is average velocity, which it does go into, and I think it does a pretty good explanation of that. I think it does V as AVE, V average. These are all the same thing. So when you see those, but with velocity, direction matters. So I just wanted to show you some examples of how that works. So here's Kyle. Oh, it's not really Kyle anymore, but sure, it can be Kyle. Maybe it's Kylie. Runs 3 miles left for 30 minutes and then 2 miles right for 10 minutes. What was his or her average speed, and what was his or her average velocity? We can say there. Then we're okay either way. So let's look at the person down here that's running. So they run. So if we're looking at average speed, we want to know the total distance that they went. So this person went 3 plus 2. So if I'm looking at speed, they went 3 plus 2 miles. All right, we won't have our units in there, but I'll put it there. And they did that in a total of 40 minutes. So 30 plus 10, right? So their speed is therefore 4 or 5, I wrote it right, divided by 40. Well, let's see, 5 divided by 4. Well, this is 8, right? So that's basically 1/8. In physics, we tend to use decimals. We don't use sig figs, yay. So that's about 0.125 miles, what were we doing, per minute? Miles per minute. I didn't put my units in here. This was in minutes, right? So the average speed, S, is 0.125 miles per minute. And then if we look at their average velocity, though, they went 3 this way and 2 that way. So their total displacement is just what's left, which is 1, right? Because it's 3 minus 2. So if I look at how far this person is from where they started, it's 1. So that means that their average velocity is going to be 1 divided by that same 40, because it still took them 40 minutes. So it's 1 mile, 40 minutes, and I plug in my calculator, 1 divided by 40, and that comes out to be 0.025 miles per minute. So you can see that's not the same answer, right? 0.025 is not the same as 0.125. So the idea is if they're looking for average speed, remember you add up the two distances. So just remember that I added. So there's the big difference. Whereas if I was figuring out for velocity, I subtracted, right? This was 3 minus 2, where this one was 3 plus 2 for the total distance. Concepts. Get the concepts. We're going to do more with math and doing it the correct way later. For now, I just want you to get the concepts, and then we can add the math to it. Then they talk about this concept of instantaneous velocity. So I wanted to pose this question. Does your car measure instantaneous or average velocity? Well, average is on average how much displacement you had per time. But your car speedometer doesn't measure that. Your car speedometer measures how fast you're going right at that moment, right? If it says 35 miles per hour, that's how fast I'm going right at that moment. So it's instantaneous. And technically, it's a trick question because it's not really the velocity. Technically, it's the speed because my speedometer does not tell me the direction, right? It only tells me how fast I'm going. So if we have a position time graph, remember we talked a little bit about position time graph, we know that if the rate stays the same, that my speed stays the same. But if I want to find my instantaneous velocity at any point of time, I can just find the slope at any point, right? Because that's the rate of how fast I'm going. So I want to remind you that slope, right, is rise over run, which would be my velocity, right? And you just have to divide it into sections. So I can see I've got 3 sections. So let's change the colors for each one. So if I look at my green section, right, and I looked at my rise over my run, so let's do that in blue maybe, right? So here's my rise over my run. And let's say this is 2 seconds and 4 meters. Then for section 1 right here, right, my average velocity would be my rise over my run, which would be 4 over 2, which would be 2 meters per second. But if I look at this next section, let's make that yellow. Oops, I tried to make it yellow. This section right here, which is yellow, what's the slope of a horizontal line? That's right, it's 0. So this is section 2. So V2 would simply be 0 meters per second. So the instantaneous velocity during that little section, they could be referred to as time, or it could be referred to for at that position, whatever it happens to be, is 0. And then we've got this last section, which we'll do in black. So this one right here, which we'll call section 3. And now if we do the rise over the run, it's still got to be 4, right? Because that's not going to change. But let's say that person does it in 1 second. So notice that the slope is negative, right? Because it's going down as opposed to going up. So my instantaneous velocity for that section would be 4 over 1, but it's negative. So it would be negative 4 meters per second. Okay? So if we knew calculus, we could go a lot further on this. I think it briefly mentions it. Don't worry about it. We're not going to do anything with calculus. So we're just looking at slopes. You're just looking at slopes. And we all learned slopes in Math 1. So you should be able to find the slope of any straight line section. And that will tell you the velocity, the instantaneous velocity for that section, right? In the green, in the yellow, or the black, right? If, on the other hand, I wanted to know what the average speed was for the entire section, and let's say this middle section, the yellow one, let's say that was also 1 second. So if I wanted to know the average speed for this whole thing, I could still use the graph because I could say, oh, I went a total of 4 plus 4, right? I went 4 plus 4 meters for my total distance, and it took me 2 plus 1 plus 1, 2 plus 1 plus 1 seconds, so that would be 8 meters over 2, 3, 4, over 4 seconds. So my average speed, not my instantaneous, my average speed would be 2 meters per second. My average velocity is even easier, right? Because look, I ended up where I started. So my average velocity is 0. Cool, right? So you can do that for anything that you just have to read the question to make sure you understand what they're asking for. What do you think's happening in this graph? So they talk a little bit about this, and we're going to go more into detail later, but just looking at it, what is happening? Well, let's think slope. So if you're thinking slope, look at the slope here compared to the slope here. Do you notice how this is very steep and this is not steep? I don't know what else to say. It's not steep, it's pretty flat. And then here it's steep, right? But it's negative. This is steep, but it's positive. So we know that the rate is how fast it's going. So here we have a really high positive velocity. So I'm going in that direction, in the positive direction, really, really fast. And then here I slow down, right, as the slope goes down. So then the velocity slows down, and then they reverse directions and they come back. And so we come back in the negative direction. So this is an object that is speeding up. And when we say that velocity is increasing, our physics word for that is acceleration. Now, we're going to talk more about acceleration later. You guys use it incorrectly sometimes. But we actually have, this is still accelerating over here. This is just negative acceleration, and this is positive acceleration. And that's just telling me the direction. I'm still going faster, right? So I'm going like this, and I'm going really fast, and I go slower, 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 stop. Slow, slow, fast, 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 and then I'm going really fast. So that's what that graph is telling me. I start fast, I go to a 0 slope, I turn around, I come back, and I'm going fast again at the end. Again, concepts, concepts, concepts. And, sorry for that little blip in there. When I was looking at some of the math help or some of the math problems, I just want to make sure you get this because this is not really physics, this is math, and I want to make sure you understand it. So remember when we were saying we wanted to figure out average speed and velocity? It really doesn't matter in this case because he's going in the same direction, right? This person keeps walking in that direction. So average speed and velocity, if you go in the same direction, are exactly the same. But the thing is, it words it funny. So it says, like, if I move 2/5 of my total distance for 2 hours and 6 kilometers for the rest of my distance in 3 hours, what is the average speed? So I kind of drew the picture to help you understand. So 2/5 of my total is what I did in 2 hours. And I did 6 kilometers for the last part in 3 hours. And remember, when I'm trying to find speed, in this case, displacement too is the same. I need to know my total displacement because it's going to be the same in this case. And I know I did that in 5 hours, so that part's fine. But the problem is I want this delta x, right? So, but if I know that 2/5 of it is this section, to make it a whole, this is 3/5, right? So that means 3/5 of delta x is equal to 6, right? Kilometers. So that means if I want to find delta x, I just take 6 and I multiply it by 5/3. I go to my calculator and I go 6 times 5 divided by 3, and that comes out to be 10. So if he's going, this is really the thing I wanted. Now I could then go back and say, oh, well, if the total, so this is going to be 10 meters in 5 hours, so it's 2 meters per hour, right, is the answer. But I could also go back if I wanted to, so I could figure out what the average speed was here. I could say, oh, well, if the whole thing's 10, remember this plus that has to equal 10, then I know this little section has to be 4, right? So that's just some math, not so much the physics, but I thought that might be helpful. All right, there we go.